Welcome student. In last lecture we discussed historical representation of atomic structure in that Dalton theories, then we discuss Rutherford theory, limitation of Rutherford theories, then Bohr's theories. Today we are going to start new concept, that is atomic spectrum of hydrogen atom. According to Rutherford model, since electron can occupy all the position from wall 10 raised to minus 12 centimeter to the size of atom 10 raised to minus 8 centimeter. Thus the energy of electron must be continuous. Hence the atomic spectrum obtained by the emitted radiation must be continuous. However, the observe that the atomic spectrum consists of discrete line, thus it is discontinuous, and Rutherford model could not explain it. Atomic spectrum of hydrogen atom. Rutherford model are failed to explain the discontinuous line or discrete line. So, according to Bohr atomic model Bohr atomic model could successfully explain the line spectrum of hydrogen atom and also the species like helium, lithium, beryllium, etc. Line spectra are caused by the energy transition taking place within an atom. Line spectra are also called as atomic spectra. Line spectra are also called as atomic spectra. It provides information which can explain the arrangement of an electron in the atom. The line spectra or atomic spectra arise due to transition of an electron in an atom from higher energy level, that is excited state, to the lower energy level. Thus it called as atomic spectrum or is an emission spectrum. The line spectra or atomic spectra arise due to transition of electron in an atom from higher energy level. From higher energy level it come back to, or excited state, it come back to the lower energy level. It means higher energy level it come back to the lower energy level, and it called as atomic spectrum or is an emission spectrum, is called as emission spectrum. It is an see the diagram. High voltage hydrogen gas, high voltage tube, hydrogen gas in that tube, slit, radiated energy, see the radiated energy, prism and detector or photographic plate. Line spectrum, then the line spectrum are obtained for the hydrogen, or it is either it is visible region or not. Hydrogen spectrum is obtained by passing a electrical discharge through the hydrogen kept at a low pressure. Hydrogen spectrum is obtained by passing electric discharge through a hydrogen it kept at lower pressure. The emitted radiation is analysis and only a few lines of a different wavelength are observed in the visible region of this spectrum. Through this spectrum as a whole contain many lines. It contain many lines. Come closer as the wavelength lambda increases until the continuum reach. It was found that this line can be grouped into a series, which suggested that these lines were related to each other. Atomic spectrum of hydrogen consists of a several spectrum line. This is because excited state of electron is short-lived. Hence, electrons jump back to the lower energy level available to them. Actually, hydrogen gas tube at low pressure they are uh, it passing through in hydrogen spectrum. In that tube, electric discharge, it passing through the electric discharge, and we get a spectrum. Some line are closer or group into a series. It means it suggests that the line were related to each other. Next, see here, atomic spectrum of hydrogen atom spectrum. White light is made up of all the color of the visible spectrum. Passing it through a prism, it separate it. When white light, when see here, when white light is passed through a prism, then after the passing through the prism, they are separated. See here, here is one color, and see here, here is different color. Next, spectrum, white color made up of all the color of the visible spectrum. Prism, when white color is passed through the prism, there is a single color, but after passing through the prism, they are separated it. If the light is not white, by heating a gas or with a electricity, we can get it to the give off a color. Passing this light through a prism does something different. Atomic spectrum, fingerprint of an atom. See here, each element give off its own characteristic color. Here is hydrogen, hydrogen emission, hydrogen absorption, then hydrogen emission, carbon absorption, carbon emission, oxygen absorption, oxygen emission. Means they are each element, means each element, hydrogen, either carbon, oxygen, gives off its own characteristics color. Atomic spectrum, these are called as line emission spectra. These are called as line emission spectra, and the light is emitted given off are called as light emission spectra. Next, hydrogen spectral line. Bohr calculated the energy, frequency and wave number of the spectral emission line for the hydrogen atom, and that calculated by using this formula. Bohr calculated the energy, frequency, then frequency and waves number of the spectral emission line for the hydrogen atom, and that given by the following formula. The wave number of a different spectral line can be calculated corresponding the value of N1. It means N1 is an energy level. Next, Bohr explained for the hydrogen spectrum. According to Sir Bohr's, when current is passed through a hydrogen gas, when current is passed through a hydrogen gas in the discharge tube at a low pressure, the molecule of hydrogen break to the atom. When current is passed or electrical discharge, it passing through the electrical discharge, hydrogen gas in the discharge tube at a low pressure, the molecule of hydrogen break into the atom. This atom absorb energy from the electric spark and they get excited. See here, it is ground state, it is excited state, energy in, they get excited and goes to the excited state or higher energy level. The electron of hydrogen atom are excited to higher energy level. The higher energy orbit to which electron migrate depend upon the amount of energy absorbed by the electron. The higher energy orbit, see here is one orbit, suppose here is second orbit. when electron get excited, how much, here or it position, it may be this position, it may be this position. Suppose there is two orbit, it's depend on amount of energy absorbed by the electron. Excited state, photon out, ground state. This excited state electron being unstable and come back to one of the energy level. They are come back to one of the energy level, and the electron may come to the lowest energy level. In this way they emit energy they had absorbed. Actually, when electron absorb energy is in, then they get excited. It's depend on how much energy is absorbed. Then at a particular time, this excited electron being unstable, and they are come back to the lower energy, or to one of the lower energy level, and the electron may come to the lowest energy level. In this way they emit energy, and they had absorbed. Next, there is various spectrum of hydrogen atom, that is Lyman series, Balmer series, Seychen series, bracket series, and Pfund series. N and N2 are energy level, then spectral region and wavelength, it is given by the unit Armstrong unit. According to Bohr model of an hydrogen atom, each orbit allow to the motion of electron is a characteristic by the value of shell number, that is n is shell number. The shell or energy level value of n is equal to 1 has a lowest energy. Actually, n is an shell number or energy level. The lowest energy, n is equal to 1, has the lowest energy, and other energy level with higher value of n possess successively higher energies. Thus, the only electron of an hydrogen atom occupy the first level of the lowest energy in a normal or ground state. When energy is imparted to the hydrogen gas in the tube, electron move to the higher energy level with value n is equal to 2, 3, 4, 5, 6 and 7, depending upon the quantity of energy is absorbed. From this higher energy level, that is N2, the electron return by the jump to the one of other lower energy level, that is N1, giving up a excess energy by the emitting or quantum of the radiation. Thus, the energy associated with emitted quantum of the radiation is equal to the difference in energy of two energy level involved in the electron jump, depending upon the lower energy level to which the electron jump it rise to give a various series, that is given in table. Various series of hydrogen spectrum, that is series, then energy or cell level. N1 is an lower energy level, N2 is an higher energy level. Spectral region means spectral region, wavelength, that is Lyman series. Lyman series is arise when the excited electron from higher energy level, that is excited electron means higher energy level is start from where N2 is equal to 2, 3. It is an higher energy level, return to the ground state, that is N1 is equal to 1, that is first energy level, or it called as K shell, and it is observed in ultraviolet region. Wavelength is 920 to 12,000 Armstrong unit. Balmer series. Balmer series arise when excited electron from higher energy level, where N2 is higher energy level. It start from N2 is equal to 3, 4, 5, etc. Return to a lower energy level of L cell, that is N1 is equal to 2, and it is observed in visible range. Then such a series NH N1 is equal to 3 and N2 is equal to, it is an higher excited energy level. It start from N2 is equal to 4 and it is observed in infrared region. Bracket series, that is lower energy, that N1 is equal to 4 and N2 is equal to 5, 6, or it higher energy level is 5, 6 to the lower energy level, that means N cell. Fund series arise due to transition of excited electron from higher energy level, that is N2 is equal to 6, 7 to the lower energy level, that is N1 is equal to 5, and it observed in infrared rays. Next, Heisenberg uncertainty principle. Heisenberg uncertainty principle. According to uncertainty principle, it is impossible to describe simultaneously and precisely both the position and velocity of an electron at the same time. Heisenberg stated that the more precisely we can define the position of an electron, the less certainly we are able to define the velocity of an electron, and vice versa. If delta x is an uncertainty in defining the position of delta v is the uncertainty in the velocity, the uncertainty principle may be expressed mathematically as given in equation. That equation is here: delta x and delta v is greater or is equal to h upon 4 pi. We will stop here. Thank you.